Hello everyone, and welcome back to the second lecture of this series that talk about claims and science. And just to recap from our last lecture, so we talked about deduction versus induction and the different meanings of these, and we gave a few examples of each. We talked about science and what science means and the scientific method, and we also talked about some characteristics of the modern science. So before we move on, I highly recommend that to get the maximum benefit of these lectures is to follow the sequence of the lectures as is. And in order for you to understand this lecture, you will need to have some concepts that we discussed from the last lecture. So I highly recommend that you, first of all, you watch all the lectures to get the maximum benefit. And number two is to follow the sequence of these lectures. So just to recap, so deduction and induction, we mentioned that deduction or deductive arguments, the conclusions follow with necessity from premises. And we mentioned that inductive arguments, the conclusions follow with some degree of probability. So we're not, or we're never certain when we use induction, and in the modern science, we use induction, and therefore here we're talking about probability and most likely and less likely kind of discussions, and strong evidence or weak evidence, which is opposite to deductive argument, where your conclusion could be either valid or invalid. So here is a funny tweet that I saw on Twitter, and this is a kind of a joke actually by this person who mentioned, dear New England Journal of Medicine, I have 2 cats and I'm currently not intubated. All of my patients this week that were intubated did not have cats. Conclusion, cats prevent severe COVID. So I have huge respect and appreciation to the respected journal, New England Journal of Medicine. However, this is just a joke by this person. And just to give an example of this kind of argument that this person made, is kind of funny, and it's actually a form of deduction. However, the premises that he uses to reach his conclusion, the conclusion is actually not valid. So this is a kind of a funny argument and a funny deductive argument example. So here we're going to talk about in this lecture knowledge and how do we acquire knowledge, and actually what knowledge means. So knowledge, I put some Arabic words here for the Arabic audience. So basically what we're trying to do during our studies and things that we do is we actually want to reach the truth, and we want to have knowledge of certain things. So the science that talks about knowledge is epistemology, which we'll talk about in the next few slides. However, to reach the truth or to acquire knowledge, you can do that through different ways. So this is at least the way I understand how we can get to know the truth. There are different ways to reach the truth. This could be either through religion or deduction or induction, in other words, modern science or empirical evidence or empiricism. Okay, and for deduction, for example, in deduction, we use logic to reach the conclusion or the truth. In religion, we use belief. So we use belief to reach to the truth or conclusion. So in the this section here, which is empiricism or empirical evidence, induction, in other words, here we use experiments. So we do experiments, we collect data, and then we reach to a conclusion. Okay, so uh, I think this slide is very important because it really helps you understand how different people think. And also, um, when you think about arguments and claims, it really makes you understand how the person who's putting the claim thinks. So, for example, if you're using religion beliefs as evidence, so in this side here, it is really hard to jump between these different ways. So, for example, you cannot convince someone with a strong religion belief and a certain claim with modern science, or the other way around. So, I think knowing how the claim is, or how the claim, from where the claim is coming, is really important. So, let's just say, for example, that a person mentioned that in his religious belief, he thinks that certain kind of food is curative for cancer. Well, that kind of evidence comes from this side of the chart. So it's us as scientists. It's really hard for scientists to come up with um, a kind of arguments against this or the other way around. I think we have to recognize from where we're coming, and we have to recognize the tools that we're using. Here we're using the tool experiments, whereas here we're using the tool belief. And these different ways are not necessarily um, um, let's say overlapping. So uh, this could be a truth, and whatever that claim is could be a true thing. However, it's really hard to jump between these kind of ways. So we have to keep this in mind. So epistemology means, it comes from the word episteme, which is a Greek word, means knowledge, and logy, as we know, is the study of. So basically, epistemology is the study of knowledge. And this is the philosophical discipline which studies the nature of knowledge. So um, basically, it asks questions like, what is knowledge, and how is knowledge acquired, and to what extent it is possible for a given subject or entity to be known. Uh, so for knowledge, and to understand what is knowledge, so I highlighted three different types of knowledge that we know. So now we know that for a certain kind of um, let's say, a fact that you want to reach, you know, usually we know that, we know how, and we know by acquaintance. What I mean, an example here, for example, in math, we know that 2 plus 2 equals 4. So we know that kind of information, or that kind of conclusion. And we also know how to add 2 plus 2. So knowing that and knowing how are two different things. And we also know number 4. So knowing number 4 by itself is knowledge by acquaintance. So knowing a person or a place, or we know that, you know, that thing is called a car, for example, or this thing is called an airplane or whatever. So knowing by acquaintance. Epistemology is mainly interested in number 1. There is another very important concept called knowledge as justified through belief. So justified through belief. In order to explain this concept, so here's this slide, and I put different colors on each word, because this concept relies on 3 different words, and they are important to understand this concept. So justification is one thing, truth, and belief. So what justified true belief says is, let's say a subject S knows that, again, we're talking about that in knowledge, that a proposition P is true if and only if P is true and S, the subject, believes that P is true, and S is justified in believing that P is true. So this is called justified true belief. And there's something called Gettier problem. Gettier is an American philosopher who had a problem with this justified true belief. And he actually said this is not the only way to explain knowledge. And he gave a few examples where justified true belief could be false or could be wrong. Okay. So this leads us to another important slide of explaining something called externalist and versus internalist belief and debate of knowledge and where knowledge comes from. So externalist, so they respond to the Gettier problem to say that for justified true belief to account as knowledge, there must be a link between the belief and the state of the external world. So in other words, the reality of anything or the truth lies outside of our mind. So there is a link between the external world and the belief, and then we have to find that causal link through doing studies, observations, etc. The internalists, in other words, they assert that all knowledge-yielding conditions are actually within the psychological mind or the psychological states of those who gain knowledge. So there's a debate between these different schools of thought. Okay, so when it comes to medicine, how do we know in medicine? Well, we use different kind of themes. So we use evidence-based medicine. We also use expert opinion from our teachers, from our professors at universities, from authority, from different books, etc. But we really have to recognize the limitations of evidence-based medicine. And here are a few examples of that. So we know that evidence-based medicine requires generalizability to be of any use. So whatever study or experiment you're using, you're doing that sort of sample from a much bigger population. And then when you reach to a conclusion from that sample, you have to generalize the conclusion to the whole population. And so the generalizability is another very important topic that we will discuss later when we explain the difference between internal validity and external validity. External validity talks about generalizability. Another limitation of evidence-based medicine is that we always end up having a degree of statistical confidence with some degree of uncertainty. And this is actually a core feature of modern science, as we explained before. Actually, we are never certain about anything. We actually put things in words of probability. Okay, unless you can falsify things, you can disprove, as we said, you can disprove things, but you cannot prove things. And we usually, when we have that certain degree of probability, then we tend to believe in that evidence and accept it until we get a falsified observation. Um, I hope that you remember the example that we gave about the penguins before, where we said having one white penguin will disprove the hypothesis of that all penguins are black. So another limitation that I think is really important and it's very relevant to the time being of COVID-19 coronavirus pandemic is sometimes waiting for evidence may be harmful. So for example, let's just say an example that a drug X is useful, or a method of treatment X is useful for COVID-19. If that drug is useful and that is the truth, However, in order for us to reach the truth, we will have to do a randomized clinical trial, which might take time to do it or to conduct. So waiting for evidence may be harmful. And actually, if you look into the human history, there are a few examples of actually having really harmful effect while waiting for evidence. And a famous example of this is the Crever inquiry. So what happened in Canada that led later on to the initiation of the Canadian Blood Services. I recommend you to go back and read about this. However, back then, thousands of patients got exposed to tainted blood products in Canada, and they got infected with HIV and hepatitis C, because one of the reasons why that happened is that there was no evidence that transmission of hepatitis B could happen from blood products. However, of course, at that time, there was no evidence. However, it is risky to wait for evidence in some situations. Not all situations, but in some situations, waiting for definitive evidence can be risky. Now talking about positivism versus post-positivism, the modern epidemiology relies on empiricism, as we discussed, empirical evidence. It comes from doing experiments. So doing experiments and getting the evidence out of it. Whereas post-positivism talks about actually theories, background, knowledge, and values of the researcher that can influence what is observed. So there is a belief by some people that the researcher, his own mind, basically, based on theories, values of the researcher, it may influence the observation. So positivism mainly says reality basically is external to the mind of the knower and accessible through observation. So there is a cause and effect, and basically, and we're trying to know that link, whether it be a correlation or causation. We're trying to identify some risk factors, exposure, and get that into models, talking about causation and correlation, etc. So another important concept is critical realism. This is a very important concept for any scientist or anybody who has interest in science to actually understand. So critical realism is a branch of philosophy that distinguishes between the real world and the observable world. Basically, what this means is that the real cannot be observed and exist independent from the human perception theories and constructions. So basically, you cannot separate human mind, the mind of the researcher, from the observed data. Okay, so we have to always know that what is being observed is not necessarily what the truth is. Okay, so this critical realism, recognize observations or observation could be fallible. So there is a chance of error. So there is a chance that the data could be wrong. And there is a chance that the study conclusion is actually false. And independent, I cannot separate this from the human perception theories and constructs. Okay, this is a really important slide as well. Probably the most important slide in this lecture. And really, I want everybody to think of these kinds of types of evidence while you hear any kind of claims nowadays about COVID-19. So, uh, so sometimes we hear different claims from different people. Sometimes they are expert or let's say professors in universities or otherwise. And in order for us to think about what kind of evidence or what is the rank of this evidence, what kind of is it a strong evidence or a weak evidence, we have to go back to this slide and think um, and to put it in one of these types of ranking. So here we start from 1, which is the weakest kind of evidence, to 11, which is the strongest kind of evidence. So you will hear, for example, different kind of advertisements for different kind of ways to treat a certain disease. For example, hearsay. In Arabic, we say al-qil wal-qal. So people say this drug works. People say this increases your immunity. People say this and that. Well, this is not actually a strong kind of evidence. Okay, so number 3 is testimonials. So I heard that person X uses this kind of drug and he got cured. I heard that person Y actually died because of using that kind of drug. So testimonial from other people about certain kind of things are not believed to be a strong kind of evidence. Testimonials from friends and authorities. So you will get people coming to you and says, well, you know what? My mother got cured from cancer while using that kind of drug or that kind of food or whatever. So this is a kind of testimonial, and it is from a trusted person. Maybe it be your friend or an authority, maybe professor in the university comes to you and says, you know what, I have cured a person by doing positive energy sessions. So what that means, I don't know what that means. However, this is a kind of testimonial from an authority, or the professor in the university, for example. Well, again, this kind of evidence is very weak. Sworn testimony, so maybe they will swear that this kind of treatment is effective. Recorded observations. These also can be used as a type of evidence. So from number 1 till number 6, I consider all of these as weak kind of evidence, 1 being the weakest. And when it comes to a higher hierarchy of evidence, so number 7, 8, 9, 10, 11, I would say these are the types of evidence we use in modern science and an empirical kind of evidence. So number 7 talks about recorded systematic observations. So doing an experiment in a systematic way and get some kind of data or observations. Okay, number 8 is recorded results of interventional experiment, randomized controlled trial. Number 9, recorded results from replications of the experiment. So we have randomized clinical trials showing that that drug is effective, and then you get 2 or 3 other replication of the same kind of data. Here we have a very strong kind of evidence. Number 10 is successful predictions based on model derived from systematic observations. Again, here we're talking about statistical models, prediction models that you can use through different types of statistical ways to predict information derived from data from systematic observations. And number 11, which is probably the strongest kind of evidence, is successful predictions based on model derived from experiments. So if you have a prediction model, a statistical model that is derived from multiple randomized clinical trials, so this is a kind of a very strong evidence. So some people will, of course, be attached to the idea that experts, people, um, can be a source of evidence. Actually, if you go back to this slide, sorry, we're going forward. We have to go backward. Okay, so if you go back to the slide and think of experience, it will be probably around the number maybe 3, 4, 5 at the best. So it's considered to be a weak kind of evidence if you have an expert opinion. In medicine sometimes, or in science sometimes, we use something called anecdotal evidence, or basically an authority, a professor or whatever, telling you that that kind of treatment is effective. Okay, so uh, again, this kind of evidence or anecdotal evidence is really weak. Okay, this is a funny cartoon saying that, okay, I've cut my hand, doctor, and the doctor says, rub this salt in it, and then it becomes very painful. And of course, the doctor says, well, okay, now we know that it is painful to put salt on wounds. This is another funny slide that I found on Twitter. So I did not make this slide. However, I thought it is funny and relevant to the current situation of COVID-19. And this person who made this slide talks about hierarchy of evidence and putting randomized clinical trial at the top of the pyramid. At the bottom of the pyramid, he gave us some examples of where some people says, folks or people saying that there are some kind of remedies or treatments to cure COVID-19, like garlic, for example, or using whatever other kind of weird treatment. This is, of course, a very weak kind of evidence. Then we have uncontrolled selection bias data sets from France talking about study related to COVID-19. Then compassionate use, uncontrolled data with massive missing data and selection bias. Then randomized clinical trial for registration with no control arm and or no blinding, referring to one study that used an antiviral drug without control arm in COVID-19, and hinting to the top of the pyramid, hinting to the fact that maybe having a randomized clinical trial with a very strong evidence is a fairy tale. It's something that probably will not have, and it may not happen. So I just found that this is a nice slide to share. Of course, WhatsApp is a commonly used platform that most of us, if not all of us, uses, and there's so many claims out there that we hear every day. And of course, I'm sure everybody has already watched this professor from France who talked about COVID-19 and how this virus is actually resembles HIV, and it's invented in laboratory, etc., etc. So I'm not going to talk about that claim or how to refute that claim, or not expert in virology. However, what I would say is that I go back whenever I hear any kind of claim like this, I go back to the slide and try to think what kind of evidence this is. I highly respect that professor, and I know he's a Nobel Prize winner, etc. However, at best, whatever he's mentioning, it is probably not stronger than number 4 or 5. He is an authority in his, let's say, field. However, whatever he says is not based on empirical evidence. It is just testimonial from an authority. Okay, so it is a kind of a weak evidence that he is putting out. And this brings us to another very important point to remember, which is the reason why we have journals, the reason why we have scientific journals is because we need to have a very fair process that basically make sure that the whatever experiment or data that are submitted to science is accurate. So that is why we have a peer review process. So the peer review, when you submit your article to a journal, then your peers at the same kind of level of your scientific degree, they will basically look into whatever work you have done, and they will try to criticize and make sure that your data are accurate and your conclusions are accurate. So the peer reviewer has to verify the introductions and has to make sure that all the work is in a proper context. Uh, the peer reviewer has to make sure that the methods are used to obtain, analyze the data are accurate, they are sound, and they ask, are there any questions about the validity, whether it is internal or external validity of the data. And they would review the results if they are clear, if there's anything missing, any missing data, omitted data, anything that needs to be clarified. And also to look at the conclusion. Is the conclusion basically justified or not? And is it both based on pre-existing knowledge and whether this work has been done in the past and whether it replicates previous work or not. So any person who has submitted an article or articles to scientific journals will know that peer review process is not easy, and it should be this way. And so basically, you should think about peer review process as a way of improvement. So in order for you to improve your paper, you have to accept that you will be judged, you will be criticized on some of the things that you have done in your study, and this is something that is really important to have other people look into the accuracy of their data. So open versus closed access journals is another thing that we have to keep in mind, especially nowadays where we have so many articles out there actually without knowing whether these information are accurate or not. Of course, there are people who are proposing the idea of open access journals to have open access, free access to science. So there are pros and cons of open access journals. However, please be aware that there are journals that are called predatory journals, where basically they require fees for publications, and it turns into basically a business model where they have maybe many of them have lenient peer review. Maybe they're doing that for money, and this is actually a very serious thing, and it will end up having multiple poor quality studies in order for these journals to acquire money, which is a very unfortunate thing. Some people get confused when we talk, usually I'm a person who usually talk about how bad, it's my own opinion at least, how bad predatory journals are, open access journals, etc. And there are people who sometimes get confused because we do have very good reputable journals that are open access. And the reason why this confusion happens is because, well, we know that those journals are very reputable and they're very strong and they follow very strong peer review process. So in that case, having a reputable journal that we trust and they go with a fair, very strong peer review process, then by all means, open access to that journal will be a blessing. However, most open access journals, unfortunately, they're not at the same kind of strength, I would say. Okay, so I recommend you read this article that talks about predatory journals and how basically the world of science has become like a fast growing business, and unfortunately sucks money out of researchers, and so many different kind of scams out there that we have to be careful with. So I hope this lecture was useful, and we will move on to the lecture number 3 very soon. Again, um, any questions or any feedback about these lectures, and or have discussions in the comments. I hope it was useful, and we'll see you in lecture number 3 very soon.